Hey there guys, Mr. Carlson here. Let's take a look at another fun and exciting chemistry problem here. In this example, what we've got going on is we have a salt, a calcium bromide salt, that is going to be dissolved in water. So let's imagine that we're starting with a solid piece here, or a bunch of solid pieces of calcium bromide salt, 15 grams to be exact. And we're going to put this in some water, and when we do that, that salt is going to break apart and it's going to dissolve. So the water molecules are going to pull that apart, and we're going to assume that all 15 grams of that calcium bromide dissolves. And so that's represented right here by this chemical equation, starting off with solid calcium bromide and dissolving into calcium and bromide ions. And we also know that in that beaker we have 500 milliliters of water. And let's say that we have a thermometer in there as well, measuring the temperature for us. And before we dissolve the salt, the initial temperature was 25 degrees Celsius. And the final temperature, after all of it dissolves, the final temperature is 29.1 degrees Celsius. And we want to figure out what is the enthalpy, or the change in energy, of the dissolution. Dissolution just means the dissolving of that calcium bromide salt. And we want to calculate it in joules per gram, and we also want to calculate it in kilojoules per mole. So let's think about this. Sometimes it's a little confusing to think about whether this process is exo or endothermic. But let's think about it like this. If I'm putting this salt in here, for it to dissolve, what happens is those water molecules have to be a part of this process. And those water molecules are going to basically start to get in between these calcium and bromide ions and pull them apart to dissolve them, okay? Sometimes that process, depending on what you're dissolving, sometimes that process will actually give off energy. And if that were to give off energy, think about what that might do to the temperature of the water. So if breaking this apart into its ions releases energy, would that be endo or exothermic? And then what would that do to the temperature of the water? And so in this case, we can see that the temperature of the water is going up, which means that this must be an exothermic process. Exothermic. Because for the temperature of the water to go up, it would need to get some energy, and it's getting that energy from what's being released from that calcium bromide dissolving or breaking apart. So this is an exothermic process. So when we're dealing with calorimeters and calorimetry, if the water or the solution that you're dissolving something in, or that you're doing a chemical reaction in, if that solution increases in temperature, that's an exothermic process, okay? So now that we know that it's exothermic, let's see if we can calculate what the enthalpy is going to be. So in this case, we know we've got this equation here that we've already learned. Q is equal to the mass times the heat capacity times the change in temperature. Now, let's see what we have in this case for this to see if we can figure this out. So do we have the mass of this? Well, we have the mass of the calcium bromide salt. But in this case, remember I said that the water is part of this. So the water is part of pulling apart the calcium bromide. And so we would have to have the total mass, in this case, of the bromide mixed with the water. So we would need the mass of both the water and of the calcium bromide salt. So here's the other thing. You'll notice that in this case, they give us the grams of calcium bromide, but they don't give us the mass of the water. Instead, they give us the volume. Now, one important thing to remember, because you'll see this over and over in chemistry problems, is that if they give you the volume of water, we know that in most cases, the density of water is 1 gram per milliliter. And so if you know how many milliliters of water, you automatically know how many grams you have, because the density is 1 gram per milliliter. So if I've got 500 milliliters of water, that means I've got 500 grams of water. So now I know the mass of the water and I know the mass of the calcium bromide, which means the total mass, I'm going to write it down here. The total mass of the system is going to be 500 plus 15. So everything together is 515 grams. What about the heat capacity in this case? Whenever we're dealing with a calorimetry problem where the reaction is taking place in water, we're always going to assume that the heat capacity of the solution is just going to be the same as water. And again, that should be something that you have memorized, that the heat capacity of water is 4.18 joules per gram degree Celsius. So in this case, because this is dissolving in water, we're going to assume that the solution has the same heat capacity as water. So 4.18 joules per gram degree Celsius. And then the change in temperature. So over here, remember that every time we do a change in anything, whether it's temperature or whatever we're dealing with, if it's delta whatever, it's always going to be the final minus the initial. In this case, 29.1 minus 25 degrees Celsius. So my change in temperature is going to be a positive 4.1 degrees Celsius. So if we, let's plug this into our calculator here and see what we get. So 515 times 4.18 times 4.1. So I get this value here, 8,826.07. Now our units are just going to be joules for this, because if I look, grams is going to cancel out, degrees Celsius is going to cancel out, leaving me with joules. So now that's the amount of energy, 8,826.07 joules, that's associated with this 15 grams of salt being dissolved. Now, the problem doesn't ask me just to figure out what's the energy. It wants me to figure out the enthalpy, or the energy change, and it wants it in energy per gram and then kilojoules of energy per mole. So right now, all I have is joules. So let's take a look at this first part right here. If I want it in joules per gram of the dissolution of calcium bromide, okay? I've got how many joules, and so if I want it in joules per gram, all I'd have to do is take this and divide it by how many grams of salt were dissolved. So if we take that, divide it by 15, I get this value here, 588.4 joules per gram. So there's my enthalpy, or my delta H in joules per gram. Oh, and actually we forgot one important thing, didn't we? In this case, we said that this is exothermic. And so for my enthalpy here, I would have to make this negative. So negative 588.4 joules per gram. Now I want to get it in kilojoules per mole. So I'm going to put this down here real quick. We're going to do a little bit of converting. 588.4. I'm going to set it up like this, joules per gram. And now we want this to read kilojoules per mole. So let's first convert this joules right here into kilojoules. There is 1,000 joules for every 1 kilojoule. So if I do that step right there, that's going to get rid of joules, getting me in kilojoules per gram, but I want to be in kilojoules per mole. So the next step is I need the molar mass of calcium bromide. And let's see, the molar mass of calcium bromide is 199.88 grams per mole. And again, I set it up like this so that grams on top here, grams on the bottom here is going to cancel out. And so I'm left with kilojoules per mole when I do the math. So let's see, when I punch this in, let me see what I get here. 588.4 divided by 1,000 times 199.88, and I get 117.6 kilojoules per mole.